Now we'll review basic statistical functions. The most basic is the count function, which counts the number of non-empty cells in a range you've selected. Now Excel has two separate functions to do this. If you use the first just count by itself function, it will count up the number of cells in a range that contain numeric values. If you use the count A function, it will count the number of all non-empty cells, numbers, text. As long as it has a data value, it will be included in the count. The sum and average functions do what you'd expect. They calculate the sum or average of values in a range. The last ones in this category are the min and max functions, which identify the lowest and highest values in a range respectively. Now, we can build on these statistical functions, but instead of performing these calculations on all the values in a range, we only want to do it to a subset of them based on some sort of criteria. We call them conditional functions because they will only be performed if some criteria is satisfied. For instance, the COUNTIF function has you specify the range of data where you want to count things up, and after the first comma comes the second parameter, criteria. The criteria is where you specify the subset of values you want to count up. If you're using the SUMIF or AVERAGEIF functions, the first two parameters are the same, but it includes an additional one at the end where you specify the actual numeric values you want to add up or average. Lastly, each of these has an IFS version. That's with an S at the end. And what this means is you can impose multiple criteria, as many as you want. The difference in the formula construction is that you start with the sum or average range first, and then you iterate through as many criteria and their associated ranges as you'd like. One more note before jumping into some practice. You want to be familiar with different ways of specifying these criteria. You might want to just type in the criteria manually, hard-code it in. If that's the case, you just type in a number or put text values in quotation marks. You can use references to other cells, just typing these in. And one handy tool is being able to filter using inequalities. For instance, count up the number of sales transactions where the total amount is greater than X. To do this, you put the inequalities themselves in parentheses. This would be greater than or equal to 10. And if you want to combine this with the cell reference, you put the inequality symbol in quotes, you then type an ampersand, and then you can reference the cell like this. Now, as always, these are better demonstrated than just talked about, so let's return to our workbook. Here we have an interesting data set of all the prior presidents of the United States, how long they were in office, which political party they were affiliated with, and so forth. And we're going to try to answer the following question. Which party has dominated modern US presidential politics? If you recall, we've talked about the importance of asking high-quality questions, and we discussed how this is sometimes best accomplished by developing a line of questioning. So let's start with this one. What were the shortest and longest days in office served by a president? I'll often try to put in bold specific fields to help you know which column you should be referencing here. To do this, we'll use the min and max functions. I type in equals min, open parenthesis, and then I'll select these numeric values in column B. To quickly extend my selection, I'm going to simultaneously hold Control, Shift, and the down arrow key. That's pretty helpful. You can close the parentheses if you want. I'm just going to hit enter because it doesn't matter in this case. And we get 31. This corresponds with William Henry Harrison, the first president to die while in office. For the longest days in office, we'll use the max function and repeat this process. We've got over 4,000 days that corresponds with FDR, who won 4 elections. So now it's time to take a step back and think about what we've done here. First of all, was this question even that relevant to our overall objective? Not really. It might help us better understand the distribution of the data, give us a sense of the range of values we're working with, but while somewhat informative, the min and max of a range can often represent atypical data points. Both of these are outliers. No other president has won 4 elections, but the vast majority serve at least 1 full term. So let's try again with another question. Count the number of presidents from each of the following political parties. This is getting better. Let's just count up how many we've had from each political party and see who's been winning the most elections. To do this, we're going to use the COUNTIF function. I'm going to specify the range in column C we want to look at, hit comma, and now we need to indicate the criteria. To do this, I'm just going to make a reference to the cell to the left. This is a relative reference because as I copy this formula down, I want the lookup value, this criteria, to move in tandem. I'll hit enter. Looks like we've had 16 Democrat presidents. We'll copy this down by double-clicking the fill handle. Had 4 Democratic Republican presidents, 1 Federalist, and we have some red text here indicates Professor Snow's trying to tell you you've made a common error. But what is this? What's the mistake I made here? To diagnose the problem, I'm going to select the cell and click on the formula bar. While my criteria looks good, look, the range has shifted down. And that makes sense because I made a relative reference to that original range. As I copied the formula down, the range it was looking at also shifted down. To fix this, I'll go back to my original formula. And for both C2 and C46, the start and beginning of that range, I'm going to hit F4 to add those $ anchors in front of both the column and the row. So now when I copy this down, we're up to 19. We haven't forgotten about old Abraham Lincoln. Well, we probably already knew this, but we've narrowed down that most presidents have come from either Republican or Democrat political parties. Let's keep enhancing this analysis. Let's look at the average days in office for Democrats versus Republicans. This time I'll use the average if function. First, we indicate the range over which we need to impose criteria. That's going to be the party column. This time I won't forget, I do want to make an absolute reference there. The criteria, I'll just make a reference to the cell to the left. One more comma, and now we indicate the average range. These are the actual numeric values that I want the function to take the average of, which is days in office, column B. Again, hit F4 because we want an absolute reference to that range. 2,177 for Democrats. Oh, and it's a stark difference. Republicans have far fewer days in office. So this is adding some nuance to our analysis, right? We saw we've had more Republican presidents than Democrats, but for any given presidency, Democrats seem to have a higher average days in office. But one thing we're still missing in this analysis is we cared about modern US presidential politics. Who's been winning lately? And there's a little subjectivity there. How do we want to define what modern means? I'm not sure how to best define this, but in this final question, we can at least impose multiple criteria. Not just the party we're looking at, but when these presidents served. So pause the video now, read this question to yourself, and see if you can come up with which function best applies. Since we want to calculate the total days in office, that sounds like we're going to sum things up. And since we want to impose multiple criteria, this will be the SUMIFS function with an S. We start with the sum range, the range of values we actually want to add up. Don't forget to hit F4 to make this an absolute reference. Hit comma, and now we specify the criteria range. Where are we looking to impose our first criteria? Let's use the party. We've done it before. It's easy. Again, F4 to make an absolute reference. And now we specify the criteria. This is best handled by making a relative reference to the cell immediately to the left of the active one we're working on. But as you can see, this formula is starting to get rather built out. But if you just hit the left arrow key, Excel will know to reference the cell immediately to the left. Hit comma again, and we're ready to impose a second criteria relating to the inauguration year. We'll make an absolute reference to this range. But for our criteria, we're going to put in quotes greater than 1900. Because we used the greater than symbol, this will exclude values that are exactly equal to 1900. We're only going to consider presidents inaugurated after this year. And what do we find? They're pretty similar. Maybe Republicans have a slight edge, but we could change the time horizon. Maybe modern is after 1960. If we copy that down, they're pretty darn similar. You can try different horizons if you're interested, but from what I've seen, they're always somewhat close as long as you use a large enough window. The political pendulum really does swing back and forth pretty equally over time. I want you to try the next sheet by yourself. I tried to get another data set you'd be interested in. These are the top 1,000 movies on IMDb based on user ratings. Before jumping in, it's always helpful to review the various fields, understand the data you're working with, and then attempt the following questions. My hope is that you can do numbers 1 through 3 on your own without too much trouble. Questions 4 and 5 up the difficulty somewhat, but I encourage you to at least give them an attempt before watching my video solution here. So please pause the video now and give it your best effort. Question 1 asks, in minutes, what is the length of the shortest and longest runtime for movies on this list? Hopefully language like this prompts you to think of the min and max functions. For longest, we'll use the max function. We'll select the corresponding column of data. 321 minutes. I hope you brought enough popcorn for that movie. For shortest, we'll use the min function and repeat the process. Under an hour. Question 2, calculate the average rating of these movies for the following genres. If we want to calculate the average for a subset of the data, we need to use a conditional form of these statistical functions. Equals average if. The range on which we want to impose criteria is genre. Be sure to make an absolute reference to that range. Comma. For our criteria, I'm going to hit the left arrow key to make a relative reference to each of these genres as we're copying the formula down. And our average range is going to be the rating, again with an absolute reference. We copy that down, and interestingly, Western movies have the highest average rating. It turns out there's only a few on this list, and they happen to be the best of all those Western films that are out there. Good, Bad, and the Ugly, and other ones like that. Number 3, calculate the average box office revenues of these movies by the following certificates. Again, this should be an average if function. If the certificate, absolute reference, is the one to the left, take the average of box office revenues. About $66 million for rated G movies. PG-13 comes in first, and it looks like, there's a cost to having rated R movies. They tend to average lower revenues, even relative to rated G movies. Now, as I said before, question 4 and 5, they up the difficulty. You really have to be careful with how you handle absolute, relative, and mixed references here. Count the number of films by genre for each of the following directors. Looks like we're going to count something, but with multiple criteria, this will be count ifs with an S. There's nothing to sum or average here. We're just going to look at criteria ranges and impose criteria. For criteria range 1, let's use the directors column. An absolute reference there. Dollar signs in front of the letter and row of the start and end of the range. We hit comma. For our first criteria, I want the director who, at least for now, is immediately to the left of the cell I'm working with. But as I copy this formula to the right, I still want to reference that director. However, as I copy the formula down, I do want it to shift down a row each time. So what's the best way of doing this? It seems like I want the column but not the row to be fixed. So I'll cycle through with F4 and find the option where the dollar sign is in front of the letter K. Very good. We'll hit comma again. For criteria range 2, I'm going to select the genre column. An absolute reference there. Hit comma. For criteria 2, for now, I want to reference the genre directly above the active cell. But this time, I want the row to be fixed while allowing the columns to change. This time the dollar sign is in front of the number. Okay, that should be sufficient. I'll close the parenthesis, hit enter. Looks like Steven Spielberg has 5 action movies in this list. Copy to the right, He's got 1 adventure film in there and 2 biographies. And if we copy this down, everything works out great. Question 5 asks us to calculate the average box office revenues for films released in each of the following decades. I suppose, time and inflation is a pretty important factor when considering box office revenues, right? And we want to look at averages. If this one stumped you, I hope you didn't spend too much time here, but we're going to impose multiple inequality criteria in an average ifs function. We'll do equals average ifs, and we're going to be averaging box office revenues. An absolute reference here. The criteria range for these multiple criteria is going to be the release year, an absolute reference to that range. And for my first criteria, I want to impose a greater than or equal to ampersand and the decade immediately to the left of the active cell, comma. As a second criteria range, we'll again select the release year column, absolute reference, comma, and I want to be less than, in quotes, ampersand, and then the decade column, 1 to the left and 1 below the active cell. Close parentheses. And there we get the right answer. Don't worry about this last one. And overall, this one was tricky. I understand that. I was trying to push you there. Ultimately, I'm trying to demonstrate the flexibility with which you can use these conditional functions. In this last sheet for conditional functions, I'm not going to walk through this one here, but I've given it to you as additional practice if you're interested in trying to use these statistical and conditional functions one more time.